I'm Gab, and in this video, we are going to learn how to solve optimization problems, or the maxima and minima. But first, let us define optimization problems.
Optimization problem in mathematics, computer science, and economics is the problem of finding the best solution for all feasible solution. It is maximizing or minimizing some functions related to some set, often representing a range of choices available in a certain situation.
In solving optimization problem, there are steps to follow for an organized and correct solution. First is to draw a picture, if possible, and label the various parts. Second is to identify the objective function to maximize or minimize, as well as the constraint function. Third, solve for y in terms of x. Fourth, substitute equation 1 to objective function. Fifth, solve for the derivative and equate it to 0. Sixth, solve for y when x equals blank. And lastly, state the critical numbers from the roots of the resulting equation, which will give the desired maximum or minimum value of the function.
Now that you have learned the steps, let us now proceed to example number 1.
Problem number 1. Two positive real numbers x and y have a sum of 50. Find the numbers so that their product is as large as possible. Now, first things first, let us see if we can draw an illustration in this problem. Can we? No, it is not possible. So we are going to skip the first step and move on to identifying the objective function and constraint function. Let x be the first number, y be the second number, and p be their product. So, our objective function is x times y equals p, while the constraint function is x plus y equals 50. Next, we are going to get equation 1 by solving for y in terms of x. Here, we are going to use the constraint function. So we have here x plus y equals 50. In solving for y in terms of x, we will just need to isolate y to the left side of the equation, resulting to y equals 50 minus x. Now, we are going to substitute equation 1 to the objective function, which is p equals x times y. We are just going to substitute the equation 1 to variable y in doing so, and we will get p equals x times 50 minus x. After substituting, of course, we need to simplify, and it would result to p equals 50x minus x squared. Moving on, we are going to solve for the derivative and equate it to 0 so that we can get the value of our first number, x. Let us derive it first. P prime is equal to 50x minus x squared. P prime equals 50 d over dx times x minus 2x d over dx times x. And so our p prime is equal to 50 minus 2x. Now let us proceed to equating it to 0. Change p prime into 0. Then isolate x to the left and simplify to get the value of x. Thus, resulting to x, our first number is equal to 25. After getting the x, we are now off to getting the value of our second number, y. Simply use the equation 1 and substitute your x value to the variable x. This results to y is equal to 25. After successfully following the steps, We are now going to state the maximum product of the two numbers by saying, since x equals 25 and y equals 25, therefore the maximum product is 625.
Another example. If you were given 80 feet of wire fencing and you were to make a rectangular garden against a wall out of the fencing you have, what should be the dimensions of the three remaining sides that would create a garden of maximum area? We are going to follow the same steps as the first problem. First, illustrate and label the various parts. In this problem, we can see that having an illustration here is possible. Since we are going to make a rectangular garden, we are going to draw a rectangle and assume that it is a garden against a wall, and label it x and y as the dimensions. Next, we are going to let x be the width of the garden, perpendicular to the wall, y be the length of the garden, and a be its area. Then let's identify the objective and constraint function. Since we're asked for the maximum value, and the area of a rectangle is length times width, and we have x and y as our width and length respectively, then our objective function is a is equal to x times y. For our constraint function, since we want to find the maximum possible area subject to the constraint that the total fencing is 80 feet, the amount of fencing used would be 2x plus y. Therefore, our constraint function is 2x plus y is equal to 80. Next, let's solve for y in terms of x. Same way as the first problem. Isolate y to the left side of the equation, and we get a result of y is equal to 80 minus 2x, which is our equation 1. Then substitute equation 1 to the objective function, which is a is equal to x times y. Simplifying, it will be now a is equal to 80x minus 2x squared. With the resulting equation, let us find its derivative and equate it to 0 so that we can get the value of our x, or the width of the rectangular garden. Solving, a prime is equal to 80x minus 2x squared is equal to 80 times the derivative of x minus 2 times the derivative of x squared. And we know that the derivative of x is an identity function and it is equal to 1. So 80 times 1 is equal to 80. Then minus 2 times the derivative of x squared. Derivative of x squared is 2x times derivative of x. And simplifying, we get a prime is equal to 80 minus 4x. Now we are equating the derivative, which is 80 minus 4x, to 0. To get our x, we must isolate the variable x to the left side. So it will be the negative 4x would be positive 4x, and the 80 would be remain on the right side. Now we can see that the x variable has still a coefficient, so we're going to divide it by 4 to cancel it, and we will get the result of x is equal to 20 feet, or the width of the rectangular garden is equal to 20 feet. Then we solve for y, or the length of the rectangular garden, with the identified x value. So we are going to use here the equation 1, which is y is equal to 80 minus 2x. And we're going to substitute the x value to the x variable here. So it's going to be 80 minus 2 times 20. And 2 times 20 is 40. 80 minus 40 is 40. That means y is equal to 40, or the length of the rectangular garden is 40 feet. Since x is equal to 20 feet and y is equal to 40 feet, therefore, the maximum area of the garden is equal to 800 square feet.
Always remember, in solving optimization problems, follow the step carefully and review your solution and answers.
That's it. We hope this video helped you a lot in solving optimization problems. Thank you so much for watching and have a nice day ahead.